In the name of God, hi, my name is Mohamed Mohsen. In this project, I designed, simulated, and implemented a half-bridge converter for a small project industry. I was asked to design this converter for a transpose input. This converter should provide output voltage, a square wave output voltage with 25 kilohertz switching frequency, and the positive and negative low of the output voltage should be 50 volts and minus 50 volts. Now we are going to work on its simulation. I'm sorry. As you can see, I simulated this half-bridge converter in Plex software. I have two MOSFETs here and two capacitors, and this is the DC link. And I used these two inductors to make the input current DC. For these switches signals, I used this unit, which I designed it by myself. We have a constant here, which is going to be compared with a triangle wave, and after that, with this dead time generator, we have two complementary signals with dead time. If I want to show it, I have to zoom in. As you can see, these signals are complementary and they have small dead time. Now we are going to start the simulation. And now we have the output voltage here, which is 50 minus 50 volts. But this converter has a very big problem, which is input current and this inrush current that you can see here. So I had to design a circuit which can make the converter works softer. So now we are going to show the converter, which is in this box, and the topology on the circuit, and I'm going to explain how this circuit works. As you can see, I used a voltage divider which contains R1 and R2 and C, and the positive port of this capacitor is connected to the gate of this MOSFET. The voltage of this capacitor increases like this. After 5, though, it reaches to the threshold voltage of this MOSFET, so this MOSFET is going to be turned on, and now we have this inrush current limiter which is integrated to this converter. After showing the result of this converter, I'm going to open this box and speak about it. So as you can see, this is the setup that I'm working on: the oscilloscope, the current probe, converter, output load, and DC link, which is provided by this setup here. So now I'm going to start this. Now this is output voltage. Each unit is about 50 volts, and the switching frequency is 25 kilohertz, and duty cycle is 50%. And this is the input current. First of all, I'm going to show the result of output port, which is clear. Now I'm going to turn this off and turn it on again. This is the problem of my scope here. So now it's obvious the output voltage is clean. I'm going to turn it on. Change the time division about 1 second. Or maybe 500 milliseconds. Now I'm going to turn it on. As you can see here, I do not have that inrush current in this converter. If I auto scale it and change the volt division, that you can see the switching frequency is 25 kilohertz and the duty cycle is about 50%. Okay, I opened the converter that you can see here. This is the circuit. This inductor and this inductor, you can see them here, this one and this one. The main two switches, this one and this one. The main two capacitors, this one and this one. And the output port is here and the input port is here, and these are gate driver circuits that you can see I use to min max for preparing to isolate the voltage supply for these switches. And this is the switch that I used, and this capacitor and these resistors, these are this one R1, R2 and C capacitor. This capacitor that I used as an inrush current limiter here. And here you can see I used a blue pill STM32F1, which is here, and I used an IC charger, which I used this charger to provide this microcontroller voltage supply. And this is the back of this converter. I cannot show it easily because of these wires. And this is the first version of I used this board to implement this converter, and because this is the version, we decided to use this, and because of that we had to cut this board to put this in box. But I designed its PCB, which is here, which is clear. Two main switches, two main capacitors, outgate drivers, and this is the slot of microcontroller which provides two complementary signals. And this is the inrush current limiter circuit, one capacitor and three resistors and our switch. And this is the PCB that I designed. So, and about this microcontroller, I programmed this STM32F1, and I used a timer one which can provide outpulse, and it's not complementary signals for us. So I used timer 1 channel 1, and I did all this project by myself.